Yes, sir. Yes. Good evening, attendees.
Good evening, sir.
Right, right. Sir, is my screen available? I mean, is it visible to
Yeah,
you?
yeah, yeah. Is it available, sir?
Yeah, it is visible, sir.
Yes. So, the day two in our program, the topic we have selected is computer vision and data analysis. So here, if we talk about data analysis, we are not going to discuss any statistical methods or probabilistic methods, and we are not talking about the general form of the data available in records. So we will try to talk about the image data in the context of pixels, because it is a lengthy topic. Let it be. And how this pixel data is connected to computer vision, let us try to know, and what it is actually, and how what is its role in the present day of technology, right? So, how many of you are aware of this subfield of computer science, computer vision? Do you have any idea? Before that, before I could initiate this session, I would like to know this. Yes, computer vision. What can be computer vision?
Shaba sir, you are not very much audible, sir. Can you please check your volume, sir, please?
Okay, 1 minute, sir. Now,
Yeah, somewhat, sir. Okay, sir.
right. Am I audible, sir?
Yeah, yeah, you are audible. Yeah.
Yes. Is it better? Is it better
Yes,
than here?
little bit.
Right, right. Yes. Yes. How many of you are aware of this computer vision? Please let me know. Yes. Anyone?
What was the question, sir?
See, do any of us? I mean, from this gathering, does anyone has any idea about computer vision or any concept which they have come across related to this topic or so?
I know that computer vision is a field of artificial intelligence, sir.
Okay.
Like face recognition techniques, fingerprints, like
Mhm.
that.
Right.
X-rays, MRIs, something like that. It's one kind of artificial intelligence move. I
Okay. Okay. See, my dear people, we have two eyes. We are human beings, and these eyes are considered as one of the sense organs. Our eyes can sense the objects. Whenever our eyes they sense the objects, they receive some kind of information, and whatever the information it is received, it is differentiated in the context of different colors, different sizes and shapes. If I look at a ball, then I say that yes, it is ball. If I look at sofa set, yes, it is sofa set. If I look at my friend Abdul Ahad sir, I will say that yes, he is Abdul Ahad. And if I see, or if I put my vision towards any mobile phone, I will say that this is so and so mobile phone. So this is possible because of our eyes. And moreover, it is natural ability that our eyes are capable of capturing the information, and this information is sent to our brain, and brain will give clarity, and brain will put a sense that yes, this is mobile phone, or this is some book, or this is some ball or pen, or etc, etc. Let it be that is theory of optometry. Now let us imagine a situation where, if the same kind of ability of seeing or watching is given to a computer system, there is a computer system in your house, and that computer system is watching you whatever you are doing. If you are angry, computer will come to know that yes, this fellow is in angry mood. If you are happy, computer will say that yeah, my owner is happy. And if you are going to fell down, and if your bone is broken, and it will understand that yes, his bone is broken. And if you are playing with a ball, and the computer will say that yes, my owner, huh? my administrator is playing with a ball. How this is? If this is the scenario, is it not really a miracle? Is it not really a great achievement in the context of computer science and engineering or in this era of technology? Am I right? Yes or no? Yes? Right. And now, the same thing, the same scenario, it talks about computer vision. And computer cannot see this world itself. We know this. A computer is a non-living object. It cannot see the world itself. And now, by using some latest technologies in computer field, with the help of high level mathematics, with the help of artificial intelligence, and with the help of matrices and algebra, we are trying to produce a field where computer will be watching us and computer will gain the ability of seeing itself. So here it may be possible, it is not really a difficult task if we understand the complexity of mathematics, if we understand the beauty of mathematics. Let it be. Now let us directly come to a point. Let us try to introduce our concept of computer vision. What is this? What can be computer vision? Yes? What can be computer vision? The name itself, it is giving us some idea, vision, right? So this computer vision is a science and technology which will enable the computer machines to understand, to analyze and interpret the visual information in the same way the human beings can interpret, the way human beings can feel, the way human beings can sense, the way human beings can see and watch and understand and analyze and interpret different objects in this world. The same capability, if it is found with the computers, then it means that the computer is found with a vision. So this particular concept is treated as computer vision in our computer science. So in simple words, computer vision, it is considered as the basic or basic subfield of computer science and engineering, where we will be giving the ability and capabilities to a computer to understand, interpret and analyze the visual information, especially the images, pictures and videos. The computer will be capturing the information from the images, pictures and videos. Yes.
Hello.
you see, a machine can be shown an image of a tree or a ball or some cricket bat, etc., etc. We will be showing an image of a tree to a machine, and it will be able to recognize that it is a bat, it is a tree, it is a ball, etc., etc. How it is going to do so? It is going to do so because already it has been trained with the help of some other concept. A system is trained with the help of computer vision, and because of the training it has received, it can analyze the data points. Generally, my dear people, whenever we talk about computer vision or images or what is this videos, we have to talk about data points. But what can be these data points? Yes, what can be these data points? Can you tell me? Yes? Any response? Any response?
Yeah, repeat the question, sir.
See, what can be data points? Remember,
Sir,
remember, my dear people, vision is the highest bandwidth sense. See, I am simply trying to make you aware that what is happening internally in the context of catching the images, in the context of identifying the images. Yes, see, as I told you now, vision is the highest bandwidth sense, and it provides a firehouse. It provides how should I say? It provides a firehouse of information. And for this reason, nowadays, computer scientists have been trying a computer system some vision. And from that point, some early 1970s, I can say, from early 1970s, this area or subfield of computer vision has been evolving. And now, what is the main goal of this computer vision? To give the computers the ability to extract high level understanding from digital form of data like images and videos. Images and videos. We know that today we have smartphones, we have some digital cameras, and even a smartphone is also a small kind of computer system. So a computer is capable of capturing the images. Yes, it will capture the photos, and it has incredible fidelity, and it has some details. And in fact, a computer system or a smartphone or some digital camera is able to capture the images more better than human beings nowadays, because we have some eye problems or etc., etc. Right. Now, there is a saying, just like to hear is not same as listening. Just like to hear is not same as listening. Similar to this, taking the pictures is not same as to see or watching. The way hearing is not same as listening. Similar to this, taking the pictures is not like seeing the pictures. Right? We know this. Now you see, images on computer systems. Yes, our computer system can capture the images. Yes, let us assume that a computer has taken some image. It has captured some image because with the help of its camera. Now, images on these computers are often stored in the form of big grids of pixels. It means they are stored in the form of data points. Smallest unit of the data is considered as data point. A single unit of information, it is pixel here. Let us assume that a small point, even in our phone, on our screens, we will find some pixels. So the images on computers are most often stored as big grids of pixels, I say. Yes, we know this. And now each and every pixel is defined by some color. Suppose if I take a small image of a ball, 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 and if that image contains some 1 lakh pixels, so each pixel will be defined by a color. Each and every pixel has some color. And this color is stored. This color is stored as a combination of three additive primary colors. There may be some n number of colors. These n number of colors are because of three primary colors. What can be those three primary colors? RGB, which means red, blue, green. These are the basic and foundational colors for any form of color in a given image. Suppose if I am able to find purple color, if I could find orange color, if I could find some what is that black color, etc., etc. So all these colors are because of some combination or some intermixing of the range of values of original colors or primary colors, RGB. And now what happens here is these three colors, by combining different intensities of these three colors, we will get a value. By combining intensities of red, green and blue color, we will get some values, right? So when we get these values are called RGB values. RGB values. With the help of these values, we can represent any color. For example, let us say green color, its value is 100. Green color, its value is 100. I'm just talking assumption. Blue color, what is that? Blue color, its value is 150. And green color, its value is some 220. So if I combine these three values, 100 plus 150 plus 220, I will get some value. That value will be talking about some new color. And now I will increase the level or intensity of green color. I will make 149. Instead of 150, I will make 149. And 149, 220 and 100. Again, it will give different value, which means it is some different color. The margin or the range of intensities of the colors will be changing because of the changes in the levels or the values of these colors. Are you able to understand what I mean here? Yes, my dear people? Yes? Are you able to get my point?
Yes, sir.
Yes, yes. I mean to say there are three different colors. These are primary colors. These three different colors are found with some range of values. And based on the intensities of range of values, if we combine these three colors, we will get different colors. We will get different colors. And now, okay, up to this extent, I think it is clear. Now, because of these colors, we are able to identify the objects. Because of these colors, we are able to detect the objects. And perhaps if we talk about computer vision algorithms, the simplest algorithm or the basic form of algorithm is to track a colored object, to identify a colored object. But how it is going to track? How it is going to identify? See, it is going to identify with the help of some what is this? Records, RECORDS, records of the colors. The first thing we need to do here is to record the color of that object. Let us assume that a ball in a playground is the object. So let us assume that the playground is some, square shape, and players are playing there, and they are playing some cricket, and there is a ball, and that ball has to be identified by a computer. Computer should say that, yes, this is ball. Computer should recognize that, yes, this is ball. It is moving there. It is moving here. This is ball. Based on its movement, a computer should identify. Based on its color, it will identify that it is ball. So here, the first thing we need to do is to record the color of the ball. Okay. Let us assume that we have recorded the color of the ball. And now, in order to record the color of the ball, we will take the RGB value of the centermost pixel. We will consider the RGB value. We will take that value and we will save that value, and this value will be given to a computer program. And whenever that value is given to a computer program, that the computer program will consider that value itself as some element, the value itself as some image, which means the value will be given to a computer program or that computer algorithm in the form of an image. And now we will ask that program to find the pixel. Yes, the pixel, it will be found with the closest match of the color. Closest match of the color. See, do not get confused. When I discuss more, when I proceed my conversation further, you will understand what is happening. See, the algorithm may work in this way. The algorithm, which is meant to identify an object called ball, it may work in this way. It will start in that playground, which means the algorithm, it will scan the whole playground. I have taken the example of playground here, isn't it? So it will take the example of, which means it will scan the whole playground. So it may start from the upper right corner, and it may go on checking each and every pixel, each and every pixel. When it checks each and every pixel, and it will calculate the difference from our target color. So the color of the ball is something. Let us assume that it is some green color. And now it will go on calculating. It will go on calculating the target color. Okay, green color pixel, where it is. Green color pixel, where it is. So when it goes on calculating, what happens? After looking at each and every pixel, the best match, which is very likely a pixel, that of our ball, it will be selected. Any pixel color, any pixel's color which is going to match the pixel's color of the ball which has been already saved in the form of an image by the algorithm will be selected. Okay. And now this is very easy on a single photo. The same will be done on the videos also. How it can be done on the videos? Yes, in the form of a frame. There will be many frames in a video, and it will allow us to track the ball each and every time when it is found in the video. And now let us assume that, yes, there may be variations in lightning. There may be variations. Suppose if the match is during the evening time, so there will be difference in the intensities of light. There can be shadows, and there can be other effects. And the ball on the field is almost certainly not going to be the same exact value of the given RGB, which means, yes, during daytime, because of the difference in the variations of the light and shadows, the ball's color is different. But during night time, there will be difference in the color of the ball. But now the algorithm, how it is going to work? Yes, the algorithm will fail here. The algorithm may also show the color of the t-shirt of a player if it is going to match the ball's color. So here the algorithms will fail. So these are some basic algorithms which may fail in such contexts. Suppose if a player is wearing the same t-shirt which matches the color of that ball, even the computer system or that algorithm, it will say that even the t-shirt, it will consider the t-shirt itself as a ball. So if this is the case, what should we do now? Yes, we will depend on this technology of computer vision. So this computer vision technology, it is going to take the help of artificial intelligence. And in artificial intelligence, we are familiar with artificial neural networks. So these artificial neural networks, they will be helping this computer vision technology not to get confused with the original object and also the given object. So what are these neural networks? We know this. What can be neural networks? Anyone? Yes? Yes? Yes, please let me know. Neural networks, artificial neural networks. Any idea? Yes, my dear people. Artificial neural networks or convolutional neural networks in this context itself.
A
Yes.
connection of interconnected nodes can be said as neural network, sir?
No. Interconnected nodes is different. Network, it is network. But what is the concept or the idea behind neural networks? How these are going to work? That is my question. See, these are some advanced forms of algorithms. See, artificial intelligence is going to take the help of biological intelligence. The way the nervous system, it is going to capture the images, the way the nervous system is going to sense the information based on the same idea, based on the same concept. We are just trying to develop. We have developed, not trying to develop, we have developed some algorithms, and we have named those group of algorithms are as artificial neural network algorithms. So among those, there is one category called convolutional neural networks. These convolutional neural networks are going to help us a lot in this technology of computer vision. Okay, now here in computer vision, what happens in this context of convolutional neural networks is there will be series of inputs. So there are weights, we will multiply those weights and we will sum those values. I think I do not know whether you people are aware of this artificial neural networks, how these algorithms will be working. So if you are familiar with this, then it will be easy for you people to understand how this computer vision is going to capture the images and sense the images, right? So here convolutional neural networks will capture the images based on the layers with the in the form of the layers, and there will be some calculations. That is different issue. Now that is what it is said, computer vision is also sometimes treated as a subfield or sister field of artificial intelligence. But it is wrong. But it is wrong because computer vision is completely different and artificial intelligence is completely different. Artificial intelligence, it talks about giving the human capabilities and human form of thinking to a computer system, whereas computer vision, it doesn't talk about thinking, it talks only about seeing, it talks only about watching. So computer vision itself is dependent on the field of artificial intelligence. So we will make use of many algorithms of machine learning, deep learning, etc., etc. So in this context, I will just try to put a point. Let us consider some scenarios. I mean to say, what is this? Yes. Now there is a person. There is a person who is in angry mood, and now he is going to install a software in a computer system. A person in an angry mood or in some frustrated mood is going to install a software in a computer system. Because of that frustration, he may not be able to install that software properly, perhaps, or there can be a scope that he may miss some files, and due to that the time can be wasted, and there can also be a scope that the data may get corrupted. So in that context, if we take the help of computer vision, it will guide us. So when a computer is going to capture the images of that person, if the computer is able to understand that, oh, my owner is in angry mood, my owner is frustrated, and now he is coming to me, he is approaching near to me, he is going to touch me, and he will be asking me to install this he is installing so and so softwares, and later there will be a loss, later there may be some damage done to his computer system. So what I will do is I will not respond. It will give an image, it will give a response. My dear owner, please do not install. My dear owner, I will not allow you to install in this mode or at this stage. So if this is the case, indirectly we are saved. So in this way, in future, there can be a possibility. Computer vision is such a field where it can sense the visionary objects. Are you able to understand what I said here? Yes?
Yes, sir.
See, my dear people, now let us ask the same similar example. See, there are some automated cars nowadays. Automated cars. So how these automated cars are running? Automated cars are running because of computer vision only. It is able to capture the images, and it is able to sense those images the way our human eyes are able to sense. So all these things, it has many applications in business, in what is this, in medical field, etc., etc. This is different. So computer vision, it is going to rule. People say that artificial intelligence, but more powerful than field of, which means more helpful than artificial intelligence will be computer vision. If we deeply analyze, it may take the help of artificial intelligence, but more powerful, I mean more helpful, not powerful, more helpful will be computer vision, because it will guide us. It will avoid many problems which we are going to face. And now, but see, just now I told you how it will be working with the help of a small example of a ball in a playground. Now remember, computer vision applications will make use of input from the sensing device. Perhaps the sensing device will be camera. See, simply I'm discussing. I'm just delivering a talk. I'm not trying to explain you all the things, because explaining is much complicated. Within this span of time of 1 hour, explaining everything, each and every concept is different. I'm just putting the shortcut edges by touching each and every concept. See, it will take the input from sensing devices. Perhaps the sensing device will be the camera. And now it will replicate the way human vision works. I told this. Computer vision applications run on algorithms, and even I told you that the algorithms will be trained. These algorithms will recognize the patterns, and these patterns will be used to determine the content of the other images. I told this. Yes? And now, behind the working stage of all these things, all these algorithms, what is involved? Deep learning is involved. What is deep learning? Extension of machine learning. Deep learning and machine learning. Deep learning and machine learning are going to help artificial intelligence. This artificial intelligence is going to help computer vision. So the deeper sense of information, understanding, interpreting, and analyzing the deeper sense of information can be made possible using deep learning algorithms. What simple machine learning algorithms cannot do, those things the deep learning algorithms can do. So here in computer vision, the major role is played by deep learning algorithms. Okay, a sensing device will capture an image. The sensing device will be camera, right? And now this image will be sent to another device called interpreting device. The interpreting device will use some pattern recognition algorithms. These pattern recognition algorithms will break down the image. And now after breaking down the image, there will be different patterns in the form of the pixels. All these pixel patterns of the image will be compared, and then at last it will be determined if any of the content in the image is going to match with the given pixel or the feeded pixel or not. The pattern could be something in general. For example, it can be any object like ball or pen or sofa, etc., etc. Or it could be some unique identifier such as facial features. Your face is different, my face is different. So that is what our facial detection systems are going to work. Facial detection systems, they involve computer vision technology. They will just try to analyze the distance between two eyes, the height of the nose, the breadth of the nose, the size of the lips, chin, and which means the area of the eyebrows, etc., etc. Based on that, they will give clarity about the image. Yes, when I stand in front of that facial detection system, it is going to recognize me. But simply it is not, directly it is not going to recognize me. Before it is going to recognize, already my image has been captured. It is found there internally. And that image will be matched when I come next time with this new image, when I stand in front of it. The matching context will be done with the help of the pixels, just now as I told you. First, we will give the image. Later, that image and its pixels will be matching with the new image when I stand next time in front of that facial detection system. If the same pixels are found, then it will say that, yes, you are the real faculty member. Yes, you can go inside. Otherwise, it will say that, no, fault image. You are fake faculty or you are fake person, whatever it may be. So it happens internally like that. So whenever a user requests some specific information about an image, the interpreting device will provide the information based on its analysis of the image. That is called interpretation. And first it will understand what is given to it, and then it will analyze what has come to it, and then it will interpret whether whatever it has come is going to match whether whatever it has been received. So in this way, these computer vision algorithms are going to work internally. How these computer vision algorithms are working? Because of the role of deep learning. In modern day, see, the example which I gave, those were some traditional algorithms, but the modern day computer vision applications are shifting away from statistical methods. Earlier, in 1990s or 2005 or 2010, we were using some statistical methods, some algebraic formats, some matrices, etc., etc., in order to analyze the images, and we were depending on all these things. But there are some limitations if we use those. Though these concepts are revolutionary, though these concepts are highly acceptable and highly helpful, but there are certain limitations. If we are applying this computer vision technology in real-time applications, those concepts may have some limitations. So we are relying on deep learning theory. With deep learning theory, a computer vision application runs on a special type of algorithm called neural network, just I told you. And this algorithm or these neural network algorithms will allow it to deliver even more accurate analysis of images. Compared to statistical methods, more accurate analysis, more accurate interpretation of the images can be done with the help of deep learning algorithms. And here, the deep learning algorithms will allow this computer vision program to retain the information from each image it has analyzed. When it has this capability, when it has achieved such a capability, then what is going to happen? The accuracy will be increased. Accuracy will be increased. So if accuracy is increased, then it means that there is perfect match. I do not know up to what extent you are able to understand. Sorry to say this, if you want to understand all these things within this span of time, we should have the knowledge of many other fields, especially neural networks and statistical methods. And you might have come across this multimedia rich applications. You might have taught the subject of multimedia rich applications or computer graphics. So if you are able to understand the theory of computer graphics, then it will become very easy for you people to understand the technology of computer vision. Computer graphics plus deep learning is our computer vision. Advanced computer graphics, high level computer graphics can be treated as computer vision. In simple words, if I say this, are you able to get my point? Yes.
Yes, sir. Yes, sir. Please
Right.
continue.
Right. And you please see, there are generally what happens in computer vision technology. There are 5 steps. First is image acquisition. So after image acquisition, then image pre-processing, then again feature extraction, then object classification, and then object identification. And even at last there can be object tracking also. Nowadays we will also find object tracking. So what happens at the earlier stage is image acquisition. What is this? The first step in computer vision, which means acquiring the visual data, capturing the image. This image, the data can be in the form of images or videos. We know this because we are talking about the digital data. Yes, the data can come from various sources. It can be received or it can be achieved. It can be captured from cameras, sensors, or some existing databases. Image acquisition is the first step in computer vision technology. What is this image acquisition? We will capture the visual data. The visual data will be captured from the cameras or sensors or from existing image databases. And next, after this, the second step is image pre-processing. Before the beginning of the data analysis, before the beginning of the image data analysis, the images which have been captured will undergo some pre-processing. What is pre-processing? Simply cleaning, simply removing some noise or disturbing data. Which means we are just making some corrections. We will be adjusting the brightness. We will be adjusting the contrast so that the quality of the image which has been captured can be enhanced. So that the quality of the image which has been captured can be improved. So to improve the quality of the image which has been captured, we will just involve the technique of pre-processing. In this pre-processing step, we will try to remove unnecessary elements which have come along with the image which has been captured. And to do this, there will be some algorithms. We will ensure that we will be applying correct algorithms on particular image which has been received based on the RGB range of values. Same algorithm cannot be used for every image. Suppose if an image is found with some greater intensities or with some dark form of colors, some algorithm ABCD with name, it can be applied. The same algorithm may not work well whenever I am applying the same on some black and white image. So there will be different algorithms. So in this stage, we should be very careful in selection of pre-processing algorithms. And after pre-processing, after enhancing the quality of the images, there will be some feature extraction. What is this feature extraction? Feature extraction means identifying and capturing the distinctive patterns, identifying and capturing the features within the image, the qualities. What are the different properties of that image? What are the different characteristics of this image? So we will capture. And these features can be edges, corners, shapes, and various textures and various colors and various range of intensities, etc., etc. So what is the shape of that image, how the edge of that image it is, and what is the height of that image, and what is the texture of that image, and what are the different colors involved in that image. So all such information is extracted in this third step. So this is called feature extraction. What happens when this feature extraction step is implemented? When this feature extraction step is implemented, it helps to simplify the data. It helps to simplify the data and extract the relevant information which can be used for analysis and classification of the images, which can be used for interpretation of the images. I told you that the first step is image acquisition or image capturing, and next is image pre-processing, and then feature extraction. Feature extraction means knowing the properties or characteristics of that image which has been pre-processed after acquisition. And now fourth step, what happens in computer vision is classification of that image. After extraction of the features, the deep learning algorithms are involved. We are dependent on the deep learning algorithms, which means a deep learning model is trained. A special case deep learning algorithm, it will be trained on that particular image. Please, there is some disturbance. Right. But this deep learning model, whatever it is going to be trained, it will gain the ability to identify and classify the objects. The deep learning algorithm which is trained on that particular object or the image, it will gain the ability to identify and classify the objects. How it is going to gain? How it is going to identify? By comparing the extracted features. It will compare the extracted features. For example, yes, first time when I enter the college, if I have joined newly in a college, they will take my photograph. They will ask me to stand for biometric purpose or facial detection. They will ask me to stand in front of that biometric. Yes. At that time, the image is captured. And now the captured image has to be matched with my face whenever I stand next time in front of that particular system or device. So this matching, it is done with the help of deep learning models. The deep learning algorithms, they will be trained on the earlier image which has been captured at the first stage. Those algorithms will understand and interpret my earlier image or the first image. What is the height of his nose? What is the shape of his face? What are the features of his eyes? What is the color of his hair? And what is the area of his forehead, and how his teeth are, etc., etc. All these things will be given, which means remember, information related to particular image will be passed to the algorithm. The algorithm, it will store that information, and this particular phase is nothing but simply training of that model, training of that algorithm. Right. And now, yes, object classification is done by involving deep learning algorithms. These algorithms will be trained so that these algorithms can identify and classify the objects by comparing the extracted features. And what happens when this comparison is done? This will enable the computers to make difference between different class of objects. To make difference between different objects. It will differentiate that this is Shahbaz Ahmad Khan. It will differentiate that no, he is not Abdul Ahad. It will differentiate that no, he is not so and so, XYZ, etc., etc. So object classification is a phase in computer vision technology, I mean computer vision concept, where there will be distinguishing of different classes of objects, whether he or not, whether he is she or not, whether it is a ball or bat or sofa or pen, etc., etc. This will be decided in this step. And now object identification. What is this object identification? Object identification is extension of object classification step. It goes beyond this classification. An object identification step, it will identify the specific instances of the objects within an image. Yes, it will identify specific instances, I am telling. Whatever the image we have given, whatever the image it is found with it, so it will identify the instances of that image from different corners, from different perspectives, from different views. And now, after this, what happens? This will be done with a scene. A scene is developed. Yes. When I stand second time in front of the facial detection system, now if it is able to identify if there is correct match, now it means that yes, there is a scene, there is a correct match, there is a correct match. Right? Are you able to understand? Yes.
Yes.
Right. And now at last, object tracking. What is this object tracking? This is the last step it is considered. It's optional.
Sir, excuse me.
Yes, sir.
Sir, is that algorithm model is there, sir? How to it identify the size of the face, eyes? Is the algorithm is available, sir?
There are many algorithms. That is what I am telling, sir. There are many algorithms based on statistical models. There is no such single algorithm.
No. My question is how it orally calculate the each person dimension, sir. That is my question. That how to mention in that algorithm.
How to mention?
No, sir. When we stand in front of the what you call that biometric, how it automatically it calculate measure that all dimensions of the face.
No, sir. Automatically it is not doing. The algorithm is trained with the image which it has captured earlier.
Okay. So based on the earlier image, it calculates.
Yes.
Okay, fine.
Right. Where did you stop? I was telling something. Yes, image. I mean, object tracking. What is this object tracking? See, object tracking is a process where the movement of an object over the time process, which means you take a video, the ball, let us observe a video, the ball, it is in the hands of a bowler. And then it moves to the ground and then it will go to the bat and then from there it will fall somewhere, which means there is some movement of the image of that ball. So tracking of that image is called object tracking here. In computer vision, see, object tracking is related to video. Till object identification, we are just putting an endpoint to single images or simple form of images. But when we come to a video, the situation is becoming some complex. So in order to understand the image, even if it is found in the form of a video, we will just involve this additional step called object tracking. Object tracking, it is a process where the movement of an object will be tracked according to the time sequence. So the images will be found in the form of video frames in a given video. So how that image is behaving, how that image is moving, how that image is going from one point to another point, it will be tracked. So it involves locating and identifying object in each and every frame. So when it is found in each and every frame, then it maintains the continuity as it moves. The continuity of that, frame, the continuity of that object will be maintained till it moves. And due to that, and for this purpose, there will be some special other case of algorithms called tracking algorithms. These tracking algorithms are purely mathematics based, which means they will take the help of statistics, which means these are based on the what should I say, based on the range of values. At the starting of our session itself, I told with the help of a small example that there will be certain values, and according to that we'll be proceeding. That is one. So this object tracking, whenever it is done, then accurate tracking of the objects, it may not be. So there it is some challenging condition. It is some complex situation. Till now, here there is some. Here the research is lagging. Here there is no proper research till now. So still it is going on. They are trying to apply various categories of deep learning algorithms, especially convolutional neural network models. And now remember, at last I would like to say that by combining this deep learning, machine learning, pattern recognition, even pattern recognition is also part of machine learning only. Deep learning, this pattern recognition, I forgot to tell you, image processing. Image processing, it is, to say, without image processing concept, computer vision, it may not exist. Sorry to say, I forgot. Image processing, these computer vision systems will perform accurately to some extent, right? Yes. And now remember, there is some difference between, as I told you, that computer vision is dependent on the concept of artificial intelligence. It is dependent on the concept of machine learning. So we should not get confused. The primary difference between AI and computer vision is that computer vision will focus on the analysis and interpretation of the visual data, whereas artificial intelligence is not going to talk about visual data. It is going to talk about the capability of thinking. Computer vision is about seeing, artificial intelligence is about thinking. And at the same time, for both computer vision and artificial intelligence, we will take the help of the tools which are provided by machine learning theory. The techniques and tools of machine learning will be involved in order to make predictions, in order to initiate appropriate actions, in order to make identification, in order to make detections. So machine learning theory, which means deep learning only, which means extension of machine learning, deeper sense of machine learning is deep learning here. So machine learning or deep learning is going to provide some tools and techniques for development of computer vision, right? And for development of artificial intelligence also. And now whenever we talk about computer vision and artificial intelligence, both these things involve predictions only. By making predictions only, computer is going to interpret that this is so and so person, this is so and so object. By making predictions only, a robot or an artificial intelligence machine is going to say that yes, it is so and so thing. So prediction is going to play the role. Without prediction, without the concept of prediction, there is no concept of artificial intelligence, there is no concept of machine learning. What is this? Computer vision. So that is what nowadays, whatever the field you take, without machine learning, it is difficult to proceed and progress with that. Right? You understood?
Yes, sir.
Right. Now remember, computer vision, whenever we come across this term, there is also another term called, what is this? Intelligent document processing. Have you come across this? Intelligent document processing. This is slightly different in comparison with computer vision. Right? See, intelligent document processing, it is a technique which means which involves we have come across this optical character recognition, OCR, optical character recognition, and natural language processing, NLP. So it deals with textual data, etc., etc. And it is going to extract the data, it is going to characterize the documents, and it is going to derive the inputs or insights from the textual content. Whereas our computer vision is not like that. It is not going to talk about textual content. It is going to talk about those documents which are found with the abilities of visuality, visual elements, right? Yes. And now Let us try to talk about some general applications of computer vision in healthcare. Yes, in healthcare, there is computer vision technology nowadays. Your MRI scans, your CT scans, and what is this diagnosis of X-rays, etc., etc. All these things, these are made possible because of computer vision. So there are advanced machines of MRI scans nowadays. Earlier, the theory it was different, scenario it was different, but today we could find some different advanced machines. So these advanced machines are found with the abilities of computer vision, right? There are surgical robots also. Surgical robots are able to feel whenever these robots they perform surgeries. The robots are able to see that these are, see, when a doctor performs a surgery, the doctor, if he is going to perform a surgery related to heart, so he will touch only those parts of the heart. He will take care that he will make ensure that his scissors or his equipments or his devices are not going to touch the lungs or larynx or pharynx or some other sites in the body, because the doctor is able to perceive the information, he is able to sense, he is able to see that yes, this is wrong, this is right. When robots are going to perform the surgery, robots should also behave, robots should also sense the same what is that visual information. Robot should also not touch the other parts of the body. Robot should understand that only this area I should be able to see, the other area, even though if I am able to see, it is not my business. So these surgical robots, they are involved with this computer vision. And even finance industry or finance service, we make use of these things. In government technology, the CID people, they will be using, see, your cameras, etc., etc. In retail, the main importance of computer vision is found in healthcare only. Other than that, I don't think that it is found. Yes, in commerce industry or in business industries like automobile industry, it is playing a role nowadays in foreign countries. I do not know whether it is happening in India or not. Yes, the automatic cars, they involve this computer vision. Without computer vision, there will be no chance of this running or moving of automatic cars. But what are the challenges of this computer vision? I mean, what are the problems we face? See, though there are many benefits, so there are some challenges with this computer vision. What can be challenges? Complexity and variability of the visual data. The visual data, it always varies from point to point and time to time. Suppose if I watch an object during daylight or sunlight, its color is different. And if the same object is kept during night time, there will be some variation in its color. So because of that, there will be confusion to the algorithms of computer vision. So it is one barrier, it is one complexity. And at the same time, the high degree of variation due to these lightning conditions, backgrounds, shadows, object appearances, so it is going to confuse the algorithms. So there will be no strong algorithms, there will be no robust algorithms, and due to that, the computer vision technology may fail in those cases. So this is still a point of research. Understood? And at the same time, another challenge is availability of labeled data. So what is this labeled data? Yes, yes, sir. There is some difference, sir. Asif, sir, there is some difference. I mean, there is some disturbance.
Asif sir, please can you mute yourself, sir? Asif sir, please mute yourself, sir.
And now remember, yes, another difficulty which we will come across computer vision is availability of the labeled data. In order to train the models, in order to develop some accurate models of computer vision, we require some large and a large form of labeled data sets. The training, it requires some large amounts of labeled data sets. So when we have selected large amounts of data sets, and if we have provided those large amounts of data to the algorithm, it is time consuming, and moreover it will be expensive, and moreover it may introduce the problems of biases and what is, yes, bias problems. So it is also one of the challenge here. Yes, yes, there is some. Sir.
Sir.
Yes, yes, there is some disturbance. Right? Right. Yes. till now, full-fledged computer vision has not been made possible, and in future it may be easily accessible, it may become scalable, and it may be even become adaptable for simple business scenarios. Till this point of time, full-fledged and pure form of computer vision is not yet achieved. Whatever the theories we have learned or whatever the theories we have come across, those are only theories. The practical implementation or practical scenario, the other side, it has not been achieved till now. So in future we may expect these technologies to become more accessible, more scalable, right? Yes. Yes. I would like to stop here itself because I have approached the target time. So there are only 5 minutes. So please, if you have any questions.
Sir,
And
excuse me,
sir,
sir.
last, yes, sir. 1 minute, sir. 1 minute, sir. Last point is, it is also helpful. Computer vision, it is closely connected to augmented reality. Computer vision, it enhances the features of augmented reality. See, augmented reality is simply a fake world. We know this. Augmented reality is a concept where we will try to make simulations of real-time objects. So in augmented reality, in order to make simulations, this computer vision is required. So augmented reality is dependent on computer vision again. So if you enter the deeper sense of computer vision, we will come to this point of augmented reality. Yes, sir. Yes. Rahmat, sir.
Sir, my question is with reference to artificial intelligence and computer vision, what are the aspect of whether we take picture as an input or video as an input, with reference to image, what is the aspect of computer vision in terms of image recognition and image classification? In the sense with reference to image differentiation and just to let us know the classification of image, which of the method is been used with reference to image classification, with reference to images, or if at all it has been a video, how that particular classification is done with reference to frames.
Sir, that is what I am telling, sir. Frames, pixels, okay, videos, right, images, all these are part of computer graphics. And whenever there is a video, this video is nothing but combination of several images. If you take 100 images and if you just move all these images with the help of your finger on a screen, it looks like a video. So in that context, in order to recognize any image according to the data which has been trained, according to the image which has been given first, there must be classification. Without the step of classification, without the mode of classification, recognition becomes difficult. So for classification, there are some hundreds of thousands of algorithms available in our machine learning or deep learning. Even for recognition, there are hundreds or thousands of algorithms. And these algorithms will which means differ in the context of the size of the data, shape of the data, or format of the data. Suppose if I am using black and white image, the algorithm ABC, it may not be suitable. It may be suitable to some very good image which is found with many colors. Suppose if an image is found with some limited number of colors, so we will use different algorithms. So whatever the question you have put, it is something like a theory only. I mean, we have to go to the deeper sense. We have to talk about the working structure of the algorithm.
Okay, sir. Okay.
Right. Next. Any questions, please? Any questions?
No, sir.
Right. Right, sir. And again, here there is a form. These people have asked you people to fill the form. So, right, let it be right. Ahad, sir? Ahad, sir?
Sir,
Yes. Shall we conclude?
yeah, sir, we can conclude, sir.
Right. Thank you, sir.
Faculty members, if you have any question, please raise it. And one more thing, I request you to, I have sent one link. please sign that. That will be recorded as the attendance for today's.
Okay, sir.
Okay. Thank you, Shabas sir.
Right. Thank you.
Yeah, thank you, sir.